Okay, good morning ladies and gentlemen, welcome to another lesson video. Today we are going to look at a very simple topic, which is of course Pythagoras theorem. This is a grade 9 topic, which of course comes mostly in paper 1 of grade 9 final examinations. So today our main focus will be finding just on the Pythagoras theorem sides in the right angle triangle. We need to be able to identify and to know the sides in the right angle triangle. Once we know the sides in the right angle triangle, dear ones, we shall be able to answer any kind of a practical questions that they have given us. So let us begin. Lesson number 1, sides in the right angle triangle. The longest side in a right angle triangle is called the hypotenuse. The longest side in a right angle triangle is called the hypotenuse. Okay, the hypotenuse. Okay, doesn't matter how you pronounce it, just know that it is hypotenuse. You can pronounce it that way as long as you know that the longest side in a right angle triangle, it is the hypotenuse. Okay, so now we come to the next point. It is the line always found opposite the right angled as shown below. Now, this hypotenuse, it is a line always found opposite the right angles as shown below. So the right angle, it is simply the demarcation. This is, let's say this is my I need to formulate a triangle with my arms now. Okay, you see this? This is my biceps is quite big. So if I formulate a triangle here which touches this length, this angle which is here, it is the right angle triangle. This is the right angle. Now this angle which is here, it is always opposite to the hypotenuse. So this distance from here to here, it is what we call the hypotenuse. That is what they are talking about. We shall see that in a real drawing. The other two sides are called adjacent. Now, you remember, this is my triangle. If I formulate this triangle, it will be like this, of course. Now, these two sides, this one and this one, it is what we call the adjacent. These two sides are what we call the adjacent. But the one here on top is the hypotenuse, which is opposite this angle. It is the hypotenuse. So this and this, it is my adjacent. Good, we shall see how it looks like. So these two sides are called the adjacents. Okay, now here is a right angle triangle here. This is what I was trying to demonstrate with my hands. Now here is a right angle triangle. You can see this length to this length. It is my arm when I had folded my arm like this. Now in this manner, I folded my arm like this. So this side and this side, it is the adjacent, but the side opposite the right angle triangle. In other way, how do I know that this is a right angle triangle? When you see this symbol which is here, this represents 90 degrees, this represents 90 degrees, and this is a right angle triangle. So every angle opposite this triangle, it is what we call the hypotenuse. This is what we call the hypotenuse. Okay, that one. But what about these two other sides? This is what we call the adjacents. These are adjacent. And also this side is also the adjacent. So we have now come up with the proper definition of whatever the right angle triangle is about and the sides. Now we know that the longest side is the hypotenuse. As you can see, this is the longest side between these two distances. This is the hypotenuse, and this is the adjacent, and this is also the adjacent. Now let's continue, move on, and see if we can answer the question that comes, if we are able to identify. I know some of you, Mutinta especially, you are saying that these are very simple things. Of course, you are right, Lily. These are simple things. Let us see how we can answer them. Example. Name the hypotenuse. We are naming what? The hypotenuse in the diagram below. Now, this is a very simple question and a very simple, straightforward question, which I expect Joseph to be able to answer this question. Okay, I expect Jonathan to be able to answer these questions because these are very simple questions. Okay, now let us look at this answer. Now, Anderson, if you name the hypotenuse in the diagram below, Anderson, I expect you to be able to answer this one. Now you know the hypotenuse, adjacent, and adjacent. So what is the hypotenuse? Okay, let's start with the triangle ABC. So when you look at the triangle ABC, let's look first at the triangle. Okay, let's look at this triangle first. Triangle what? ABC. What is my hypotenuse in this triangle? What is my hypotenuse? Look at this one. The 90-degree angle or the right angle, it is opposite to the hypotenuse always. That is the statement there. So automatically my hypotenuse in this scenario, it becomes this one. When you follow this one, becomes my hypotenuse for ABC triangle. Hence AC, it is my hypotenuse. So we are going to say from ABC, the hypotenuse, okay, the hypotenuse, we can abbreviate it by saying the hypotenuse is equal to what? AC. AC is my hypotenuse. Okay, we have identified the sides. Now let us come to another triangle which is ACD. Okay, let us come to another triangle which is of course ACD. Let us see ACD, or we can say, okay, ACD. Okay, ACD. Now, ACD, the hypotenuse here again, we can abbreviate it as HYP is equal to what? What is the side of the hypotenuse? Look at this length. This is the, how this angle, it is how you know that this is a right angle triangle. So we are saying that the side opposite this right angle triangle, it is what we call the hypotenuse. So for ACD, the hypotenuse, it is simply DC. D what? C. That is the hypotenuse. Hence we have identified that part. Hopefully this was very easy for you to be able to answer. So once you identify the sides, then now we can move on to something interesting, which of course it is the Pythagoras theorem itself. What does the Pythagoras theorem state? Remember, Pythagoras is the person. Okay, he came up with this theory when, of course, it was a time of era when people were trying to find out some way of how they can do the shares, how they can divide, they can share this, divide into equal parts and stuff like that. Of course, these we are talking of the Chinese and the Indians, how they were trying to do all those kind of calculations. Of course, they were using other means of calculating, but it was giving a lot of time. It was wasting a lot of time. So Pythagoras came up with the way of how to solve question, of how to find solutions easily without wasting time. And this now he came up with a theory that states that the square of the hypotenuse, meaning the square of the hypotenuse is equal to the sum meaning the addition, to the sum of the squares of the two adjacent. To the sum of the squares of the two adjacent. So we are simply saying that the two adjacent, when we square this adjacent and square this adjacent, it is equal to the sum of the hypotenuse squares. Okay, that is what they are simply telling. That is the Pythagoras theorem. Now let us put it in this scenario. Given a triangle PQR such that PQ is 90 degrees, which means it's a right angle triangle, it follows that PQ and QR are two adjacent, okay, side, while PR is the hypotenuse. Thus, the Pythagoras theorem states that PQR, which is the hypotenuse, is equal to PR squared is equal to PQ squared plus QR squared. So this, in other words, dear ones, it is the formula for finding any kind of equation in a right angle triangle, as long as we are talking of the sides that we need to find in a right angle triangle. This is the formula that we need to use according to Pythagoras himself. Okay, so now let us see how we can answer questions using this formula from examination papers. Let's start with number 1. Okay, so before we do the example, let's look at the note first. Note, the theorem is used to calculate the length of any two sides. You are calculating the length of any side of a right angle triangle. Remember, this should be a right angle triangle, okay? The right angle triangle of a right angle not the length, I mean the triangle here. Given the other two sides, given the other two. So meaning that you are going, if they give you two sides, then they ask you to find another side in a right angle triangle, you can use the Pythagoras theorem. You can use the Pythagoras what? Theorem. Let's look at the example here. Example. Using Pythagoras theorem, calculate the missing side in the figure below. We have A and B. We need to use Pythagoras theorem to calculate this. So how do we calculate this? Let us write our solutions here. Solutions. Let's say solutions. Solutions for the first part. A. We have a triangle. Let's redraw the triangle. We have a triangle which is drawn in this manner, and they tell us that this side is my 4 centimeter, and this side is 3 centimeter, and this is Q, this is P, this is R there, and always remember this is a right angle triangle. So it's a right angle triangle. They have given us two sides, and they ask us to find the other side. So we are going to use the Pythagoras theorem to find this side. Now we know that this longest side is the hypotenuse. So for me to be able to answer this question, I need to say PQ, which is the hypotenuse, PQ squared is equal to, you can start with QR, if you want, QR squared plus Q what plus QP squared. You can write it like that. Then just replace and be able to calculate your weight. It doesn't matter how the formula, you can say RP or PR, or you can say QP or PQ is one and the same. What matters is, do you know the theorem? Yes. Then apply it. Then we want to find PQ. So what is my QR? QR, it is 4 centimeters, so 4 squared plus, what is QP? QP, it is 3 centimeters squared. What is 4 squared? 4 times 4, it is what? 16 plus 3 times 3, it is 9, equal to 16 plus 9. What is 16 plus 9? That is 25. Okay, 25. So we know that we have PQ squared. Now we need to find PQ, not PQ squared. We need to find PQ. So we need to get rid of this square. This square. How do we get rid of the square? Remember, we did look at index notation. So in index notation, we know what square means. Square means 1 over 2. So it means that we need to introduce the square root in other way. So we're going to say PQ squared. We introduce the square root on both sides. Of course, 25, the square root. So that this square and this can go. Then I have PQ is equal to, what is the square root of 25? 25 is a perfect square. So what is the square root of 25? Which is 5 centimeters. Yes, this is the answer for PQ. PR. Now, not PQ, PR. Where am I finding PQ? It's supposed PR. PR, not PQ. Okay. It's supposed to be PR. So it is PR. PR. So PR, the distance PR is equal to 5 centimeters. Now, to go back to the theorem states that the hypotenuse, the square of the hypotenuse is equal to the sum of the two adjacent. Now, well, in other ways you can interpret this one is the hypotenuse is the longest side, so it's supposed to have the biggest number. If you find the smaller number of the hypotenuse, just know you are wrong. Look at this. We have 4 centimeters, 3 centimeters. These are adjacents. But the hypotenuse, it is 5 centimeters. This tells you that your working is correct because the hypotenuse is the longest side between these two sides. Hence, it's supposed to have the biggest number. Okay? That is how you work out this one. Now, let's see you do B. You do B. As for me, I'm done from here. Let's see how you do B. Okay, do B. Alright, B, let's work it quickly here without wasting a lot of time. we draw the triangle. Okay, this is a right angle triangle. They are telling me this is 6 centimeter and this is 10 centimeter. Okay, this is 6 centimeter. Let me just draw my triangle nicely. They are saying that this triangle is like that. We go like that. Then we have it like this. Okay, somehow like that. Yeah. So we have 6 centimeter and we have 10 centimeter. Then we have, this is my B and this is my A and this is my C. So they want us to find the missing side, which is AC. As you can see there, they want us to find AC. So how do we get to find AC? We get to find AC by simply coming up with a formula for this diagram. Look here, the diagram was PQR, but now here we have ABC. So we can simply say this is AC. So write the Pythagoras theorem using the distances there. So we start with the hypotenuse, which is BC squared is equal to AB squared plus AC squared. Okay, just put it like this. The hypotenuse is always, these two I need to add them. So in other words, you can now continue replacing. What is BC? BC is 10 centimeter. Okay, we just write 10 squared is equal to AB 6 squared plus AC squared. I don't know AC squared. So it means that I need to collect the like terms together so that I get to find AC. So how do I collect the like terms together? This 6 squared will cross the equal sign and it will come this side. So it will be 10 squared minus 6 squared is equal to AC squared. So what do I do next? I need to simplify this. What is 10 squared? 10 times 10 is equal to what? 100. 10 times 10 is equal to 100 minus 6 times 6, 36. We have 36 is equal to AC squared. AC squared. So once we have this one, therefore now let me just carry this question and bring it here. What is 100 minus 36? 100 minus 36, that should be 64. So I have AC squared is equal to 64. AC squared is equal to what? 64. Now, just the same way we did with this one, we also need to get rid of the square here. So we need to introduce the square root and say AC square is equal to 64. We introduce the square root on both sides so that this square and this square root can cancel. AC, therefore, it is equal to what? 8 centimeters. So it means that I found my answer to be 8 centimeters. Now, when you look at the answer there, you are able to tell that this answer is quite big than the other, is quite smaller than the other hypotenuse side. Look at this one. We have 10 centimeters, which is the hypotenuse, but these two are adjacent. So this 8 we have found is smaller than this one. That tells you that the hypotenuse is always supposed to be with a big number. Okay? Once you find if this was 15, then I know that there is something wrong I did with my calculation somewhere there. So you need to always keep in mind that the hypotenuse should have the big number than the rest of the adjacents. Okay, hopefully I've made this one clear for you. Next video, it will just be ECZ examination questions that we shall do for grade 9. Of course, we shall see how complicated sometimes they may ask questions. So don't miss the next video, because the next video, it will be of complex Pythagoras theorem questions that we need to practice on. For now, let me just leave you with this knowledge and the content. Hopefully you have understood. If not, please comment in the comment box, and I'll be able to reply to you. And please do pause the video, copy the notes, put them in your notebook so that you can be able to refer to it anytime, anywhere you feel like revising mathematics. This is the end of Pythagoras theorem, or I mean the first topic of Pythagoras theorem, which is of course identifying the side and practicing the practical work. As for now, I call it a goodbye and enjoy the rest of the time. Bye-bye.